In this video, we're going to discuss the difference between ionic and covalent bonding. In ionic bonding, electrons are transferred from one element to another, and typically ionic bonds contain ions. In a covalent bond, electrons are shared. But let's go over ionic bonding first. Let's consider the reaction between an atom of sodium and an atom of chlorine. Sodium, as an atom, has one valence electron. If you look where it is in the periodic table, it's in the first column. It's in group 1A of the periodic table, and elements in that group all contain one valence electron. A valence electron is simply the electrons in the last or outermost energy level. Chlorine, which is a halogen, contains 7 valence electrons. It's in group 7A of the periodic table. The halogens are very reactive nonmetals, and the alkali metals, where sodium is found, are very reactive metals. Metals like to give away electrons, and so they form positively charged ions. Nonmetals, they like to receive electrons, and so they form negatively charged anions. So sodium is going to give chlorine one of its electron, or valence electron, since it only has one. So as sodium loses that one valence electron, it's going to acquire a positive charge. And as chlorine gains that electron, it acquires a negative charge. Now, going back to physics, if you have two like charges next to each other, what's going to happen? Like charges repel. They're going to feel an electric force that repels them or pushes them away from each other. But what's going to happen if you have a positive and a negative charge next to each other? These two are attracted to each other. They feel a force of attraction that pulls them together. And so that's what's happening between the sodium ion and the chloride ion. The sodium ion, which now has a net positive charge, is attracted to the chloride ion, which has a negative charge. And so these two, they feel a force of attraction. And that force of attraction, that electrostatic force, it binds them together. And so that creates the ionic bond. So keep this in mind. Within ionic bonds, you have a transfer of electrons, and the bonds that hold them are as a result of the electrostatic forces between opposite charges. Keep in mind, opposite charges attract each other. So now let's move on into covalent bonding. Let's look at hydrogen. A hydrogen atom has one valence electron, and it's in the first row of the periodic table. Elements in the first row, they want to have a total of 2 electrons in their outer energy level. The second row elements, they want to have 8 electrons. So elements like oxygen and fluorine, they want to satisfy their octet. They want to have 8 electrons. But hydrogen and helium, they can only have 2 electrons in their first shell. So each of these hydrogens, they need one more electron to fill that first shell with a total of 2 electrons. And both of these elements are the same. So what they're going to do is they're going to share their electrons. And so these two, they're going to form a bond. So when you see a bond, this bond represents the sharing of 2 electrons. And so this is a covalent bond. Anytime you have sharing of electrons, it's a covalent bond. Now there's 2 types of covalent bonds you need to be familiar with: polar covalent bonds and non-polar covalent bonds. The bond between 2 hydrogen atoms is considered to be a non-polar covalent bond. The reason why it's non-polar is because the electrons are shared equally between those 2 hydrogen atoms. Now, if you look at the bond between hydrogen and fluorine, the elements are different. Fluorine is much more electronegative than hydrogen. Because fluorine is electronegative, it's going to pull the electrons toward itself. Now, granted, the electrons are still being shared, but they're being shared unequally. And whenever you have an unequal sharing of electrons, you have a polar covalent bond as opposed to a nonpolar covalent bond. So because fluorine is more electronegative, as it pulls the electrons toward itself, fluorine is going to acquire a partial negative charge, and hydrogen is going to be partially positive. And whenever you have an object where one side is positive and the other side is negative, you have a dipole, you have a polarized object. And this is what it means to be polar. You have an unequal distribution of charge. One side is positive, one side is negative. So the electrons, they're not distributed evenly in that molecule. The electrons spend more time closer to fluorine because it's more electronegative. Electronegativity is the ability of an atom to attract an electron toward itself. And fluorine, it does a good job in doing that. So now you know what a polar covalent bond is. It's a bond where you have unequal sharing of electrons. And a nonpolar covalent bond is a bond where you have equal sharing of electrons. Now, let's go over some practice problems. I want you to classify the following bonds as being ionic, polar covalent, or nonpolar covalent. So let's start with the first one. MgO, magnesium oxide. Is it ionic, polar covalent, or nonpolar covalent? The first thing I would look for is to see if it's ionic. Typically, an ionic compound consists of a metal and a nonmetal. That's how you can easily identify it. Magnesium is a metal. Metals exist on the left side of the periodic table. Nonmetals exist on the right side. The nonmetals are on the upper right side. The metals are on the lower left side. So magnesium is a metal, and oxygen, which is on the upper right side of the periodic table, that's a nonmetal. So this is going to be ionic. Magnesium forms a +2 charge as an ion. It has 2 valence electrons. So in this bond, it's going to give away 2 electrons to oxygen. Oxygen, which is a chalcogen, magnesium is an alkaline earth metal, but oxygen, it has 6 valence electrons. It needs 2 more to get to 8. So once it acquires those 2 electrons, it's going to have a negative charge. As you can see, this compound is composed of ions. Now what about 2 chlorine atoms? Chlorine is a nonmetal. Whenever you have 2 nonmetals with the same type of element, it's always going to be a nonpolar covalent. The electrons are shared equally because we have the same type of atom. Now what about sodium fluoride? Sodium is on the left side of the periodic table, so it's a metal. And fluorine is a halogen on the right side, so that's a nonmetal. So sodium fluoride contains ionic bonding. Now what about HBr? Is it polar covalent or nonpolar covalent? Now the elements are different, so that could be an indication that it might be polar covalent. But you need to run a test. You need to calculate the difference in electronegativity. If the electronegativity difference is equal to or greater than 0.5, most textbooks, they use this number. If it's 0.5 or more, then the bond is considered to be polar covalent. If it's less than 0.5, if it's 0.4 or less, then it's considered to be nonpolar covalent. So if you need the electronegativity values, you can go to Google Images and type in electronegativity table, and you'll see some tables come up. Now, I've seen different tables with different values. They don't vary much, but sometimes they do vary. So if you're doing a homework problem, use whatever table your book gives you. In the table that I use, hydrogen has an electronegativity value of 2.1. Bromine, it's about 2.8. And so the EN difference is 0.7. Therefore, this is going to be polar covalent. I'm going to write PC for polar covalent. Now, what about iodine monobromide? What is the difference in electronegativity? Iodine has an electronegativity value of 2.5, and for bromine 2.8. So the EN difference is about 0.3, which means that it's relatively nonpolar covalent. So I'm going to write NC. Again, make sure you use the table that your book provides, because if the values are slightly different, the result might be different. But the idea is that you want to find an EN difference of 0.5 or more to see if it's polar or not. So let's try some more examples. Determine if the following bonds is polar covalent, nonpolar covalent, or ionic. So let's look at carbon and hydrogen. Carbon has an electronegativity value of 2.5, and for hydrogen is 2.1. So the EN difference is 0.4. For this one, I would commit to some memory. Anytime you see carbon and hydrogen, it's going to be nonpolar. This is a very common example that you'll see within chemistry and even organic chemistry. Now, what about the OH bond? Whenever hydrogen is bonded to oxygen, nitrogen, or fluorine, you have a special case of bonding known as hydrogen bonds. Whenever you have hydrogen bonds, it's going to be polar, by the way. Oxygen has an electronegativity value of 3.5. So 3.5 minus 2.1, the difference is huge. It's 1.4. This bond is very polar. So this is polar covalent. This is nonpolar covalent. Now, if the two atoms are the same and they're both nonmetals, it's going to be nonpolar covalent. You don't really need to do the calculation. Fluorine has an electronegativity value of 4.0. 4 minus 4 is 0, which is less than 0.5. Now, calcium sulfide. For this, you really don't need the electronegativity values. You just need to know that calcium is a metal and sulfur is a nonmetal. And then so you could say it's ionic. If you have one element all the way to the left side of the periodic table and another all the way to the right side, it's going to be ionic. So that is it for this video. Now you understand the difference between ionic and covalent bonding. So thanks for watching and have a great day.